All right, let's practice a few examples where we talk about increasing, decreasing. We talk about concave up, concave down, and points of inflection. Remember on your test, I'm going to test you on, can I say, vocabulary? What I mean by that is I'll give you some fill in the blanks where I will ask you things like, when the first derivative is positive, my original function is blank. Well, if the first derivative is positive, then my original function is increasing, right? Or I might say, if my second derivative is negative, then my original function is blank. Well, this time, if my second derivative is negative, then that means my original function is concave down. Remember, first derivative tells us increasing and decreasing, and second derivative tells us if we're concave up or concave down. So I might ask you questions using that vocabulary and ask you to fill in the blanks with appropriate calculus terminology. Another one might be, if my first derivative changes from positive to negative, I've just found a blank in my original function. Well, if my first derivative changes from positive to negative, I know that I'm increasing and then decreasing, so I've just found a relative maximum, right? Or what if I said my second derivative changes from negative to positive? If my second derivative changes from negative to positive, you've just found a what in your original function? Or remember, second derivative changing signs means that you've just found a point of inflection. So making sure that you are comfortable with all of those different words, vocabulary, phrases, so that you can fill out those blanks appropriately, right? All right, we're going to go ahead and skip the second derivative test. Second derivative test just helps us find relative maximums and minimums using our second derivative. We already know how to do that using our first derivative, so we're just going to stick with that first derivative test. But let's go ahead and practice all of it. Example number 5 asks us to find all the relative extrema, relative maximums and minimums, and any inflection points for each of the following functions. So we're going to use our first derivative to figure out where we have any relative extrema. We're going to use our second derivative to figure out where we have any inflection points. So here we go. We're going to take this function, f of x, and we're going to find first derivative and second derivative. Let's go ahead and focus on one at a time. Let's go ahead and do our first derivative. Let's figure out where our critical numbers are. That's where it equals 0 or doesn't exist. Let's go ahead and figure out where our first derivative is positive or negative after we've found our critical numbers. Let's figure out when our function is increasing and decreasing so we can find those relative extrema. Then let's go over and look at our second derivative. Let's figure out what its second derivative is. Let's figure out where any possible points of inflection are, where that's equal to 0. Let's test values in our second derivative so we know where it's concave up and concave down, so we can find any points of inflection. This would be a good one for you to try. Maybe you can pause the video, do all of that, and then come back and see if you have the same answers I do. For my first derivative, I ended up getting 12x squared plus 14x minus 10. I found my critical numbers by setting that equal to 0. I tried to factor out a greatest common factor of a 2 first, and then I factored using bottoms up. Again, I have a video in Canvas if you need it for factoring. That factored into a 3x plus 5 and a 2x minus 1. I then set each piece equal to 0 and solved and got critical numbers of negative 5/3 and positive 1/2. I put negative 5/3 and positive 1/2 on my number line, and now I want to test 3 different numbers. One before negative 5/2, one in between negative 5/2 and positive 1/2, or negative 5/3, sorry, and positive 1/2, and then a number greater than 1/2. And I'm going to plug those in, remember, to my first derivative. And I'm even going to practice using my calculator trick so I can evaluate them pretty quickly now instead of doing it all by hand. When I plugged in negative 2 to my first derivative, I got a positive value. When I plugged in 0 to my first derivative, I got a negative value. And when I plugged in 1 to my first derivative, I got a positive value. That means my function is increasing, then decreasing, then increasing. And so that means I have a relative maximum at x equals negative 5/3 and a relative minimum at x equals 1/2. Remember, minimums and maximums are points. They're points in my original function where I go up and then I go down, or go down, then I go up. I want to find where these points are at in my original function. And so I'm going to plug in 1/2 into my original function for x, and I'm going to plug in -5/3 into my original function for x. Again, I'm using my calculator so I can do it fairly quickly. You should have a relative minimum at 1/2, 5.25, and a relative maximum at -5/3, 25.59. Hopefully your numbers are matching exactly what my numbers look like. Now let's figure out concavity and points of inflection. Concavity and points of inflection are found with my second derivative. My second derivative, I got 24x plus, isn't that supposed to be a 14? I don't know what happened, maybe it got erased. 24x plus 14, right? I can go ahead and take that then, there it is, and set it equal to 0 so I can find my possible points of inflection. I ended up getting a possible point of inflection at -7/12. Now it's not a point of inflection unless there's a sign change, just like it's not a relative maximum or minimum in my first derivative unless there's a sign change. So I'm going to test numbers before -7/12 and after -7/12 in my second derivative so I can see what the second derivative value is. I'm going to use my calculator, plug in a number on the left, plug in a number on the right, and I ended up getting negative and then positive in my second derivative. That means -7/12 is a point of inflection. I changed from concave down to concave up at -7/12. Remember that point of inflection is a point in my original function where it changes concavity. So I want to find the point, the x, y, in my original function. So I'm going to plug in -7/12 into my original function using my calculator to find the y value. I got 15.42. So now I have relative maximums and minimums, and I have points of inflection. I can figure out increasing and decreasing, and I can figure out concave up and concave down. You'll have multiple problems on these different ideas, so make sure you practice these types of problems. Here's another one. Look at B. If you struggled with A, or if you want extra practice, I suggest you pause the video and try this one also by yourself to make sure you got the same answer as I did. For my first derivative, I got 10x⁴ minus 20x cubed. I found my critical numbers by setting my derivative equal to 0. I then factored out a greatest common factor of a 10 and an x cubed. That left me with an x minus 2 in my parentheses. I set each of those factors equal to 0, this one, and I got two critical numbers. I got critical numbers at 0 and 2. I'm going to take those critical numbers, put them on my sign chart for my first derivative, and I'm going to test values in each one of these intervals. Using my calculator, I'm going to plug in -1 to my first derivative, I'm going to plug in +1 to my first derivative, and I'm going to plug in +3 to my first derivative to see what my signs are. I got positive, negative, and positive. Make sure you got the same thing I did. That means my original function is increasing, decreasing, and increasing again. Kind of the same shape as the last one, but not always that same shape, just happened to be that in these two examples. That means I have a relative maximum at x equals 0 and a relative minimum at x equals 2. But I want points, so I'm going to find the point in my original function where I have a max or a min. So I'm going to take those two x values and plug them into my original equation, again using my calculator. When I plug in 2 to my original equation, I get a relative maximum at 2,34. When I plug in 0 into my original, I get a relative maximum at 0,50. My maximum value is 50. That happens when x is 0. Or my minimum value is 34. That happens when x is 2. Increasing, decreasing, critical numbers, and relative max and mins. Now let's do concavity and points of inflection. My second derivative, I got 40x cubed minus 60x squared. I set it equal to 0 to find my possible points of inflection. I factored out a greatest common factor of 20x squared. That left me with a factor of 2x minus 3. I set each of those equal to 0, and I got two possible points of inflection at x equals 0 and x equals +3/2. I put those values on my sign chart for my second derivative, and I'm going to test values in 1, 2, 3 different intervals in my second derivative. All using my calculator, I'm going to use that fancy expensive calculator to evaluate -1 in my second derivative, +1 in my second derivative, and +2 in my second derivative. Ooh, I got negative, negative, then positive. So there was really only one point of inflection on this one, right? There's only one point on my graph where my function changes concavity. That happens at x equals 3/2. X equals 0 is not a point of inflection because it's concave down and then it's concave down again. It does not change concavity, so be careful. I'm going to find the rest of my point of inflection by plugging in 3/2 into my original function. Using my calculator, I got 39.875. Make sure you know how to do all of these ideas in your first derivative, your second derivative. You can factor correctly, you can solve correctly, and you can evaluate using your calculator so that you can find all of these different characteristics of these graphs. There'll be lots of different ideas on your test like this. We only have 3 sections to cover in this chapter, so this is a huge chunk of it. So make sure you're practicing all of these ideas so that you can do really well on your Chapter 13 test. Let me know if you guys have any questions.